By the Jurassic period, a group of small, feathered theropod dinosaurs had evolved into animals which we refer to as the first birds. These first birds were clearly different from modern birds and not as adapted for flight. For example, the earliest birds still retained teeth in their mouths, and these teeth would remain for tens of millions of years. The earliest enantiornithine birds, or opposite birds of the Cretaceous, possessed teeth, although they would be the first group of birds to lose their teeth. And the lineage which led to modern birds would retain their teeth through the end of the Cretaceous, as is evidenced by these fossil ornithurine birds. The loss of teeth in the modern bird lineages not only lightened the skull, but also helped to move the center of gravity to a site easier to control using flight muscles and easier to balance over the legs. Modern birds can grind their food, but instead of doing it in their mouth with teeth, they do so in a chamber of the stomach, which is very muscular, known as the gizzard, which is very close to the center of gravity. The first birds possessed a long reptilian tail like their dinosaur ancestors, but one of the first modifications as bird groups evolved was to reduce this long reptilian tail, composed of separate elements, to a shortened pygostyle, which is a fused bone composed of only a few vertebral elements. And so after the very first birds, most birds then belonged to a group called Pygostylia, which had reduced the tail to a shorter element, including a pygostyle, a fused bone of several vertebrae. In addition to lightening the skeleton, this then also helped to keep the center of gravity close to the chest. Finally, the earliest birds would have had to raise the wing using muscles which were located above the wing, like the deltoideus. However, the most efficient way to move the wing was evolved by a later group of birds called the Ornithothoraces birds, a group which literally means bird thorax. In this group of birds, the supracoracoideus muscle migrated so that its origin was on the sternum beneath the center of gravity, and its tendon passed through an opening, the triosseal foramen, so that it could attach to the humerus from above and act like a pulley. So while the muscle was beneath the wing, it was pulling on the wing from above and thus elevating it during the upstroke, which is especially important for an immediate quick takeoff. Thus, modern birds evolved over tens of millions of years, and the adaptations for flight did not exist in the earliest birds, but rather evolved over a series of intermediates. Among the changes evolved during the evolution of modern birds was the modification of the weight distribution of the bird and the center of gravity. The teeth were lost in the front of the skull, and grinding was then allocated to the gizzard close to the center of gravity. The long reptilian tail was reduced to a small pygostyle, and the major muscle responsible for the wing upstroke became the modified supracoracoideus beneath the center of gravity.